students. In the last topic, we discussed about the Darwin system of classification. According to his classification, he paved the way for arranging the then known elements on the basis of their chemical properties as well as on the basis of their atomic masses. This led to the further systems of the classification. Among them, the next system of classification is the Newlands law of octaves. John Newland was an English scientist who in 1866 classified the then known elements on the basis of their increasing atomic masses. He arranged these elements according to the musical notes. Students, do you know that how many musical notes are there? There are in total 7 musical notes. Which are these? Sa, Re, Ga, Ma, Pa, Dha, Ni. And what is the last one note? That is the Sa. As we say that the last musical note is the repetition of the first musical note. Taking into consideration this, he proposed the law of octaves. According to this system, he said that the element which is in 8th position to the first element has the properties in repetition. The physical properties as well as the chemical properties. You can see here the table which is formulated by the John Newland. Here you can see the hydrogen, then lithium, then beryllium, boron, carbon, nitrogen, oxygen and fluorine. Fluorine comes in 8th position to that of the hydrogen. Therefore, we can say that fluorine is having repetition in the properties with respect to the hydrogen. Similarly, if you take from fluorine the chlorine in the position, you will find that it is at the 8th position to that of the fluorine. Therefore, he placed the chlorine under the fluorine and the hydrogen on the basis that there is the similarities in their properties. Similarly, if you take into consideration, for example, this third one column, we see here beryllium. From the beryllium, magnesium is at the 8th position. So, according to his system, we can say that the magnesium is having the similarities in the properties with respect to that of the beryllium. Similarly, if you take this fourth one column, here the aluminium is at the 8th position to that of the boron. So, we can say that there is the similarities in the properties of both these elements. According to this classification, he was able to classify only the then known 56 elements. But later on, when more and more elements were discovered, it was found that this classification worked no longer. You can see clearly here, in order to arrange the elements so that there is the regular repetition in the properties, some of the elements, the 2 elements, he put together in one slot. For example, you can see here in the first column, cobalt and nickel, both the elements are being put together in the same column. Similarly, if you take the fourth one column, you will see here that cesium and the lanthanum, they are being put together, the 2 elements, in the same column. Why was this so? It was just only to have the similarities in the properties of the other elements so that there is the regular repetition. But this system of the classification, it was having the certain drawbacks. For example, if you take the case of the first one column, here fluorine, chlorine and bromine, all these elements as per the present system of the classification, they are the halogens. They are being put together in the same column on the basis of their physical properties and the chemical properties. But cobalt and nickel, they are entirely different in properties with respect to these 3 elements. So this was the drawback, first drawback. Similarly, for a long time, the hydrogen was being placed along with the fluorine, the chlorine and the bromine. But as per the present system of the classification, the hydrogen is being placed separately. Similarly, if you can see here, the second one column, which contains the elements like the lithium, sodium, potassium, copper, and rubidium. Out of these, only the lithium, sodium, potassium, and the rubidium, as per the present system, are now placed in the same group because there is the similarities in their properties. But the copper, that has the entirely different properties with respect to these elements. Similarly, you can see here that with respect to this one, the iron, which is placed in the seventh column among the oxygen, sulfur, and the silicon. These oxygen, sulfur, they are having the similarities in their properties. Iron has the similarities with respect to the cobalt and nickel, but these elements are placed separately among the two different columns. So this system of classification was having the certain drawbacks over there. Similarly, manganese, which is entirely different in properties with respect to the phosphorus and the astatine, they were being placed in the same column. And moreover, the Newland, he also said that only 56 elements exist in the nature, no more elements exist over there. But this was being disproved later on because more and more elements came into existence. And according to his system of classification, he could classify only up to this law could be applicable only up to the calcium. So it becomes obvious from this that this system of classification could be applied only up to the lighter elements. When more elements were discovered, this classification could not be applied further over there. Students, now let us move to the another system of classification. Various attempts were being made considering the increasing atomic mass of the elements, and the regular attempt, successful attempt, was being made by the Mendeleeve. He was a Russian chemist who in 1869, considering the increasing atomic mass and certain chemical properties, framed out the periodic table, which is known as the Mendeleeve's periodic table. This periodic table was in quite long run, for a longer time period, because of the certain facts. First of all, let us consider that what is the Mendeleeve system of classification. According to the Mendeleeve system of the classification, the properties of the elements are the periodic functions of their increasing atomic mass. Clear? Then, moving further to the Mendeleeve's periodic table, let us first of all have some concept regarding this periodic table. Periodicity means regular repetition. There are the two important points to be noted into the periodic table. One is, in the periodic table, there you will see the horizontal rows. These horizontal rows are called as the periods. And we will see the vertical columns also. These vertical columns are called as the groups. The combining of these periods and groups, when we arrange these horizontal rows and the vertical groups, we will get a form of the grid pattern, and this grid pattern gave rise to the periodic table. So Mendeleev properly on the regular basis arranged the then known 63 elements in his periodic table as per his classification. You can see, if you refer the periodic table in your books, I have made a certain pattern of this here. You will see that it contains the 8 groups. First group, second group, third, fourth, fifth, sixth, seventh, and finally the 8th group of the transition series. You will see that in the 7 groups from the first to the 7th, there are present the subgroups also in the Mendeleeve's periodic table. These subgroups are regarded as the A, B. Then similarly, the second one group as A and B, you will see clearly up to the seventh group. Each group is further subdivided into the subgroups as A and B. Then, if you consider the periods, here in the Mendeleeve's periodic table, how many periods are there? There are 6 periods. First, second, third, fourth, fifth and sixth. First, second and third period has no series. But you will see that in the fourth period, the fifth period and the sixth period, they are divided among the two series as the first series and the second series. So, he arranged the then known elements as per this periodic table. Now, what was the most important fact to be considered in the Mendeleev's classification? As I told you that he, along with the increasing atomic mass, he considered certain regular chemical properties also. He studied the chemical properties also, on the basis of which he arranged these elements. What were these chemical properties? For example, the properties of the oxides and the hydrides of these elements, for which he formulated the general formula. If you have a look again on this periodic table, you will find here right above, under the first row, what is the general formula for the oxides? That is R2O. And what is the general formula for the hydrides? That is RH. What does this R represent? R represents the element present in this particular group. Similarly, if you consider the second one group, what is the general formula for the oxide? That is RO. And the general formula for the hydride is RH2. So it means these elements which are present in the second group, in the first subgroup and the second subgroup, they all do follow these general formulas of the oxides and the hydrides when they react with the oxygen and the hydrogen. Similarly, if you take the third one group, you will find that what is the general formula of the oxides? That is R2O3. And the general formula of the hydrides is RH3. Moving to the fourth one group, you will see the general formula of the oxides is RO2 and that of the hydrides is RH4. Fifth one group, the general formula of oxides is R2O5 and the hydrides is RH3. Similarly, the sixth one group has the general formula of oxides as RO3 and that of the hydrides is RH2. The seventh one group has the general formula of oxides as R2O2 and the general formula of the hydrides as the RH. For the elements present in the transition series, as there is no subgrouping, all of them have the general formula of the oxides as the RO4. Now, on the basis of these formulas, the chemical formulas, let us consider an example. For example, if we take the hydrogen from the first one group, what is the general formula of the oxide? That is R2O. If the hydrogen reacts with the oxygen, it will form the compound known as H2O, which regularly follows this general formula as R2O, where the R stands for the element. And what is the element we have considered here? That is the hydrogen. Now let us take for the RH formula. So it means the hydrogen which we have considered as the element, in its nascent form, it reacts with the hydrogen to form H single bond H. Or we can say in the molecular formula as the 2H. But there is another concept also. The hydrogen reacts with another nascent hydrogen to form H2. Similarly, if we consider the sodium from the same group, now let us consider both the general formulas as R2O, sodium being here the element. Sodium reacts with oxygen to form what? Sodium oxide, which has the formula Na2O, which generally matches with the this one formula. Now, if we consider the another one, RH, sodium reacts with hydrogen to form sodium hydride. This again matches with the general formula RH. Students, similarly you can consider the other elements also from the other groups. For example, if we consider from the fourth group, the carbon, what is the general formula given here? That is RO2. So carbon being the element considered here reacts with the oxygen to form carbon dioxide, which clearly matches with the general formula. Again, what is the formula for the hydride? That is RH4. Same carbon when reacts with the hydrogen can form, among the various compounds, can form CH4 also, which again matches with this general formula. But this system of the classification, it was having the certain limitations also. One of the merit of this system of classification was that he left the certain gaps for the then unknown elements, and which he predicted that might be these elements are not discovered yet but will be discovered later. Therefore, he left the gaps so that these elements can be arranged very easily. Then another merit was that the noble gases, which we know they are having now the complete outermost shell, they were discovered very late and were being placed very easily in the separate group in Mendeleeve's periodic table. Another merit was that Mendeleev arranged the elements on the basis of the increasing atomic masses. As per this, there was observed the regular repetition in the properties of the elements placed in the group. Then again, as he left the gap for the then unknown elements, and these unknown elements he predicted as the Eka with the preceding element, which was being discovered. For example, Eka boron or Eka aluminium. He predicted that there might be an element which is present here next to the aluminium, not discovered yet, and he named that element as the Eka aluminium with certain properties which he proposed. And when this element was discovered later on, it was given the name as the gallium, which quietly, very easily got fit in this periodic table at its place or the space provided over there. Clear? But it was having the certain limitations, as the Mendeleev had arranged the elements on the basis of the increasing atomic masses. What does it mean? That the element which is having the lower atomic mass must come prior to its position to the next element with the higher atomic mass. But here were certain elements being placed which were having the higher atomic mass getting the earlier position to the next one element having the lower atomic mass. This he proposed so only to adjust the elements on the basis of their chemical properties. For example, as you see here, the aluminium placed in the third group and the silicon placed in the fourth group. Silicon has the atomic mass of 28.09 and aluminium has the atomic mass of 29.98. So what does it mean? That the silicon must come prior to the position of the aluminium and aluminium must come later on. But he adjusted these positions only because the aluminium was having the properties similar to that of the boron, the scandium and the germanium. Similarly, silicon was having the properties similar to that of the carbon and the germanium. But why this pattern occurred, he could not predict. Now let us consider the transition series. In this series, you will see the cobalt and the nickel. Nickel has atomic mass 58.7. Cobalt has atomic mass 58.93. So what must be the first position? Nickel must come prior to that of the cobalt. But the adjustment was only in order to have the similarities in the properties. Then if you take the fifth one group and this sixth one group and the seventh one group, you will find the tellurium in the sixth group and iodine in the seventh group. Iodine has atomic mass 126.9 while the tellurium has atomic mass 127.60. So what does it mean? The tellurium must come later to that of the iodine. But these positions were also possessing the dissimilarities on the basis of their chemical properties. Again, it was another demerit being added into the Mendeleeve system of classification. Students, merits and the demerits of Mendeleeve's that we will discuss later in the next video. Have a nice day.